multiple professional certifications spanning AI governance, cybersecurity, cloud computing, and digital strategy. Over the course of his nearly 12 years, national design and senior AI government, science facilitation, and digital over the course of his nearly 12 years, national design and 20 multinational enterprises and government organizations across Malaysia and Asia Pacific region. His professional journey includes senior role with leading global technology companies such as Microsoft, Amazon Web Services, AWS, Hewlett Packard, HP, and Telstra, where he contributed across technology leadership, governance, and strategic transformation functions. Beyond corporate leadership, Dr. Zaharuddin has contributed directly to Malaysian national development agendas, including roadmaps in AI, cybersecurity, IoT, green technology, economic transformation, and education. His academic and policy engagement include serving as a joint professor at RIUM and UTSM, membership on the MQA accreditation committee, participation in developing the program standards for computing 2015, 2020, 2023, and contributions to the new education model under the National Education Policy Committee 28. Currently, Dr. Zaharuddin serves on boards and governance bodies, including as a member of the Board of Governance of Police Shares System, and remains actively engaged in AI governance and development and responsible innovation. Very active environment. Without further ado, let's invite Dr. Zaharuddin Mansur to deliver his. Please give him a round of
Assalamualaikum warahmatullahi wabarakatuh. First of all, I'd like to thank, IUN KICT for inviting me for this case. While since I've been back here, I think last time I was invited by the legal department. Also to run my AI. Anyway, I'd like to share my thoughts on AI strategies in government in the context of enabling AI native and aspire here in Malaysia. Perhaps very quickly, it's I think I'll break the session into two sides. One is to talk about the first one, talk about perhaps stepping back a bit and understanding about AI and the national digital agenda. And then perhaps I know all of you are experts in AI, but I think I want to give a quick overview and quick update about at least from an industry standpoint, and then talk about some of the possible innovation strategies. Right? In the second half, I'll then talk about understanding what AI is. This is where we talk about governance as well as sharing some of my final thoughts in this area. So, as I said, step back a bit, I think we have to put AI in the context of the national agenda. And we cannot see AI as a standalone thing, right? It is actually part and parcel of digital transformation. Or some people say the fourth industrial revolution, right? Or the fourth phases of transformation. So, and if you think about ourselves, all of us are digital already, right? In today's world. Kita tak problem. Dulu kan, kalau kita nak jalan keluar ini tak payah 50 years ago kan. Will you leave your wallet or your phone behind? Masa tu pakai Nokia kan? Yeah. You in your wallet, right? But today, the phone first, right? Because that's where you got your credit card in there, you've got your your ID there. And for some, you even get your car keys there. All right, they even leave your car keys at home, right? So, and really, if you look at what smartphone represents, it is actually more than just a device. If you look at what digital means, smartphone is combination of this, what we call democratized technology. The internet has democratized a lot of things. One is the cloud computing, where it has reduced the cost of computing by an order of magnitude. And that has enabled things like your devices, your social networking, your right? And IoT, yes, a lot of people don't realize that inside your phone there's at least about 16 sensors. Your GPS, your cameras, your accelerometer, dan sebagainya, kan? And they are all connected to the internet. And to me, that's the best example of IoT. And what this does is generate huge amounts of data, human-generated data from social networking as well as emails and so on, but also machine-generated data from all the sensors like the phones and so on, right? And when you deal with huge amounts of data, like terabytes per day, you have to use new techniques of big data in terms of processing. No longer you can use relational databases and so on. You will be using, NoSQL storage and so on and so forth, right? But what has happened also that it is this combination of technologies, the democratization of technologies that led to actually the breakthroughs in AI. AI is not new, as I'll explain before. Now, as I will explain later. Now, if you look at this combination of this mashup of technology, it's allowed companies which was nowhere 10 years ago. Think about Grab, for example, right? 10 years ago, many of us don't even know what Grab is, right? Okay, but in a short period of time, it's become one of the most disruptive companies in this region, right? It started with car taxi and it's car hailing. And if you look at your Grab app now, what is it? It even has bought over giant supermarket, right? It does retail. It does, delivery of things. It has finance. It has hotels. It's got kind of everything. That's how a lot of these disruptive companies, right? Here it's like that, but if I think about, let's say, Amazon, which I used to work with, it is one of those early companies which is very disruptive in a very short period of time. Right? And one of the reasons why this democratized technology is disruptive is because if you think about IAUM, right? It's been around for what, 50 years? 40 years? What then? And obviously, when we think about technology, we're thinking about this, alternate improvement in terms of efficiency, in terms of effectiveness and sebagainya. But I think in this new era, it is all organizations need to also drive rapid innovation. And when you have democratized technologies enable this rapid innovation, that combination allows you to do new things at a slow rate. And that is why a lot of organizations today became very disruptive. A good example in AI, think about OpenAI, right? Before 2003, no one knew about OpenAI, right? And now it is one of the most, I would say, disruptive organizations in the world, right? They are challenging Google, they are challenging Facebook, right? They had, Microsoft had to partner with them, for example, right? So these are the kind of companies that you see more and more as they leverage on this combination of technologies. And now with AI, it's going to be even more disruptive. And it's for this reason, many countries around the world, including Malaysia, has actually come up with certain strategies in terms of driving a digital transformation agenda, and more recently, AI, an AI agenda, right? So for Malaysia, we have the Malaysian Digital Economy Blueprint 2021, and 2020 and 21 also that was to be published the AI roadmap. And I know that the new one will be 2025 to 2030, but I'm not even published yet. So we'll see how it goes. So I was involved in this development of the AI roadmap. I think the Prof. Rosalinda was also involved in this. She led the team from the UTM. And so we are very familiar with this strategy. What was very interesting back then in 2021, this before the ChatGPT came out, right? When we published this, with all the plans, with all the budget, I felt that no one was interested, right? Until Prime Minister says we are moving towards the AI nation. And that's why everyone wants to jump in and try and grab AI. So this is something that we can discuss over maybe later on for coffee. Yeah? Very interesting. Now, the economic impact of AI, how Accenture looks at it, it actually, for most countries which adopt AI early, they see at least a 2 times or 3 times increase in growth, right? So for example, if you used to be 2.5, it's about 4.5 or even 5, for example, right? In terms of GDP growth. Malaysia was a bit behind, actually. A lot of countries had already some sort of roadmap and strategies, even as early as 2016, I think. So back then when we analyzed, we looked at some of the baseline growth, even based on the fact that we were a bit behind, it was estimated by analysts that the Malaysian growth was about 4.4%. Baseline growth is 1.4%. The additional growth is actually 1.2%. If you have successfully leveraged on AI. And that's about a 30% increase in GDP growth, which is quite significant, right? In terms of enabling AI to productivity, to innovation, and so on. And if I look at the updated data points, I think it's still consistent. We're looking at, for EY, for example, talks about between 1.2 trillion to 2.4 trillion, which is about 1.5 to 2.5% GDP growth across the globe, right? In the next 3 to 5 years. And I think that's going to be a lot of, infusion of AI into all organizations in the next couple of years, right? If you don't believe me, who here is not using ChatGPT? Right? It's 100%, right? That's how infused it is. But that's your idea on this policy on AI. There you go. Big gap here, right? So we'll talk about governance later on, right? There's an interesting also report by Gartner stating that while it increases the personal productivity, one of the challenges that has not been kind of addressed is the team productivity is not as high as it should be. So I think it's quite right because people use a lot of this productivity to write summaries on the documents, right? To improve the readability of documents and so on. I think when you talk about how can a team work together and leverage on it, I think that's a bit more challenging, right? So this is one of the areas of perhaps research and investigation. How do you get to use AI in a way that systems can also benefit and become as productive as the individual use of AI? And it is, and Malaysia continues to have that interest. We see the establishment of the National AI Office, right, to drive the adoption of AI. And I think this is where, like you mentioned about the digital, the driving of the national digitization agenda for the AI nation by the this is one of the, I guess, the next version of the roadmap. Yeah. So we look forward to that. Now, where can you actually apply AI? You can apply AI to anything, really. We understand all the computer science, experts here, AI experts. You can apply AI to almost anything. Every subject of AI can be applied to so many things. So to me, you can apply it in many, many areas. It's also really confusing. It's okay. Where do I focus on? So before I go on, I just want to give a quick overview, at least my point of view, on how I define AI and looking at the technology itself. I think it's important for us, at least for the purpose of this session today, to have a common understanding of what AI is, right? So I used to be a lecturer. My first job was a lecturer, and lecturers like to define things, right? And I think it's good because it gives you an anchor on what you're going to talk about. So when we were working on this AI roadmap in 2020, we decided to use a definition which is close to what Alan Turing did, how Alan Turing defines AI, which is artificial means machines, okay, and intelligence is is actually defined as the ability to adapt to new circumstances, right? Because intelligence is very hard to define. If I ask intelligence, I, I ask each of you, how do I get a few different answers? That's what intelligence means. So, for the purpose of that roadmap, we say intelligence is about the ability to adapt to new circumstances, and we give examples such as perception, reasoning, yeah, language understanding, right? And so on. Now, this is important because if you don't define this, people will say anything is automated AI, right? So if I were to write a program, I can say this is automates, let's say, a business process is AI. It's not, because if you put this business process in something else, it will work. Or another organization will work, right? But if you, for example, I think many of us, maybe lecturers, would have a robot vacuum cleaner, right? If you think about a robot vacuum cleaner, we find it brand new out of the box, it will work in your house, right? It's not fit your house, but you will figure it out and then it will work in your house. Like this is about exactly the use of context. So this is kind of a very high level example on how automation is not necessarily AI. Right? And the reason why I say this is important is because I think recently today the Personal Data Protection Commission has published a regulation on automation. Use of automation for so this is not only AI, but it's more different programs like the automate thing. You have to it's an automated decision making. If it's a program, you have to also put a new regulation in. So one of the things as you think about the nation, okay, how do you apply in the roadmap? The focus on the use of AI to amplify human ingenuity and intellectual people. It's actually about supporting us as human beings, right? So you wanted to actually move away from the concept, let us replace humans with AI. That's not the point. But on the other hand, if we don't actually start to understand and use AI well, professionally, then I think we'll become irrelevant. That we can have life. Okay? So that is why it's important for us to embed AI education across the board, because I don't think you have to, because as I said, I mean children today are using ChatGPT, right? They're exposed to technology, and I think we shouldn't stop that, right? So one of the things as we think about how we look at applying AI, it must be based on a set of principles, right? And for the AI roadmap that we worked on in 2020, 2021, there were 7 set of principles that we recommended organizations to adopt. One is fairness, right? It means when AI makes decisions, it should be fair. It should not be, good for IIM but bad for UITM, for example, right? Secondly, is reliability, safety, and control. That's important because if you don't take care of this, then it's hard to create safe AI. You drive a Tesla, the Tesla will drive you into a pole, for example, right? You need to be safe, for example. Yeah. Thirdly is privacy and security. And these are the rights of every human being, right? So, and you don't have privacy without security. So that's why it's very tightly coupled. Number 5 is transparency. That if something goes wrong, if a Tesla hits a pole, you need to be able to at least understand why it did that, right? So that concept, as you develop AI, you need to figure out, okay, how do I make it as transparent as possible so that if something goes wrong, you can explain about it, right? The sixth one is accountability. That means if something really goes wrong, there's someone accountable of it. There's an organization accountable for it. Kita tak boleh kalau, kita langgar orang ke, masa dalam full self drive, kita kata it's not my fault. The car's fault, tak boleh. All right, there is someone's fault. Maybe it's my fault, maybe it's Elon Musk's fault, right? But there is someone accountable for it. And finally, it's about pursuit of human benefit inheritance. That's the kind of fundamentals on about the definition just now, where it says AI should be used to enhance our capabilities and our intellectual capabilities. So let's very quickly, briefly go through AI. I know all of you are experts in AI, so I'll go through this very quickly here. So as me and Prof. Tunku knows, AI is not new. It started way back in 1950, really, right? And for many years, AI we use symbolic AI. Symbolic AI is things like rule-based systems and knowledge-based systems and so on, right? Very programmatic, yeah, in many ways. It's kind of a bit more fixed, right? But if you think about it, it's that was how the early AI looks like. In fact, I was involved in developing, I think, expert system for network management for Telkom in 1993, 1994. All right. But it was not successful because, if you think about the servers at the time, when you use the Sun server, okay, to run this thing, I think your phones are more powerful than the Sun server. Right? Back in 1994, that's a problem. So, so it was not powerful. The software was very expensive because the technology has not been democratized. And I think the most important is the approach to expert systems is that we need to get the knowledge from the experts first. And the experts say, why should I share my knowledge with you when you're going to take over my job? So that was one of the main problems in expert systems in the early days. And that's why for many years, AI was quite stagnant. The cost is high, very difficult to do. Yeah. So it's only done for very specific things. But then what happened is that rather than developing AI using programming and capturing people's knowledge, we use the data generated by these experts to train the machines, right? So data is being used to kind of program the intelligence into this machine, and that's machine learning, right? In the early days, obviously, statistical machine learning, using Bayesian, using regression, whatever it is, right? And later on, you have reinforcement learning, you have things like, genetic algorithms and so on. But still, I think the real breakthrough happens when we started to breakthroughs in neural networks. Now, neural network is not new. Even in the late 80s, we knew about neural networks. We had conferences where I think computer science and biology actually came together, right? To talk about how animal brains work, how our brains work, and so on and so forth. But again, because computing was, actually very expensive, storage was expensive, don't have enough data to train, you don't get really powerful neural networks. You have these neural networks maybe doing fundamental logic and NGate processing, for example, right? Which is like, why should you use an NGate, for example. But I think the breakthrough happened for neural networks is when cloud and AI. The reason why this is important is what I mentioned just now. The hyperscale cloud computing companies like Amazon, which were Amazon Web Services, which introduced cloud computing in 2003, 2004, that really democratized computing and storage. It reduced the cost of computing storage by an order of magnitude. And then suddenly, all these researchers, all these little companies, all these innovative organizations, had access to computing and storage. And then at that point of time, the explosion of this, people are starting using iPhones and Androids, all this social networking and IoT data, which is accessible by the internet, they also had access to huge amounts of data. And that combination and that brought the breakthroughs of, deep learning, right? We started to see very powerful voice recognition. We can talk to our iPhones, we can talk to our Android phones, right? Facial recognition and so on and so forth, right? And then I think the next breakthrough was when OpenAI introduced ChatGPT, and that's generative AI. And now I'm sure you've heard about agentic AI. All right, so this kind of the roadmap it is. But again, you can see that how it's linked to the democratization of the underlying digital technologies that has enabled the breakthroughs that's happening today. All right. Just before I leave this slide, is I think all these are still relevant. Don't think that the old ways of doing symbolic AI is not relevant. I think it still is. All right. Especially with agentic AI. All right. So as you think about AI, you have this spectrum of technology approaches that is available to you, and it will be relevant in some cases, it will be not relevant in other cases, right? So you need to pick and choose and understand the strengths and the weakness of the different kinds of approaches to take. Now, if you think about the early days of AI, maybe even deep learning, it created what we call narrow AI, which is the AI was designed or trained to do really specific things, right? For example, if you do translation, just task translation. You cannot use an AI which is designed or been trained for translation to do say Q&A, right? Or to do things like summarizing and so on and so forth. So every time you have a new application, you have to train a new model, essentially. All right. So that's how the narrow AI looks like. But when you talk about foundational models, the next phase and generative AI, we're talking about models that can be used, the same model can be used for the different kinds of workloads. So for example, things like OpenAI, which is based on an LLM foundational model, you can do translation, you can do summarizing, you can do grammar checker, you can do Q&A, and many other things, right? Without you actually having to retrain the model itself. And this breakthrough happens, in my opinion, about 3 things. One is that you really now have a neural network, right, to be able to deal with huge amounts of data. Secondly is, we have in the old days we are familiar with supervised learning and unsupervised learning, right? So there is a new approach called self-supervised learning. So this is big breakthrough that has enabled a lot of these foundational models to happen. And third is transfer learning. That is, if I create this, if I train a model, I can then customize it by, using a small amount of data, right? And that's all that approach is called transfer learning. Okay, so this combination of things allows, has enabled the breakthroughs in creating foundational models where you just train one model that can do a number of things, right? So they are general purpose models. There are a few examples here. Claude, OpenAI, Mistral AI. These are all the names that you all know, right? They are all actually foundation models for a specific domain called natural language processing. So if you learn about NLP, this is kind of the next iteration of NLP, right? Ability for you to use the same model for all sorts of text-based or language-based, AI. Now, who knows how an LLM works? I'm sure you all know, guys. Okay. I think for a lot of people on the street, they kind of say, how does this work? It's like, it's like sometimes you're just talking to someone, right? But actually, LLM is, again, a huge model, right? Leveraging on self-supervised learning, huge amounts of computing, and so on and so forth. What it does, it tries to predict the next token. The next token could be the next word, next engram. You heard about engram, right? You do that NLP, right? It's actually just predict what's the next token. So if a simple one is, let's say, the token is the word, right? So if I were to type, and this you can try this out in this link here, where you just check GPT-2, if you type in the sky, what it does, it comes back predicting the next word. So is maybe it's 28%, was is 22%, and perhaps S or the skies, is 9%, right? And so on and so forth. It could be more than that, right? So if your policies take the most probable word, then you put an is. So it goes on to say, okay, it's an is, and then predicts the next, try to predict the next word. In this case, it's blue is 9%, falling is 7%, and maybe is like 5%. So I made it up. But you can try this too. Actually, we'll calculate you the probability of next word, and so on. Right? So I think the sky is blue. The next one will be either full stop or with or as and so on and so forth. Right? So and gives you a probability of the next one. So in this case, highest probability is 60. So if I take the highest probability, then that's what is cut. The sky is blue. Yeah, for example, right? So that's so essentially LLMs are just a statistical machine predicting the next token and the next word, right? And very interestingly, remember when I say that in that example I gave just now, we talked about how we take the most probable. The strategy would take the most probable word. Yeah. But actually, you have to tune the parameters. So, for example, if I tune a parameter called temperature, if 0 it takes the most likely, the most probable. If I actually go to 1, it can take, for example, say from a list and randomly takes the other one. Now, what that does is that the next time you run it, you might get different answers, right? So on one hand, it creates creativity, doesn't it? Because it gives you random answers, right? On the other hand, it also creates hallucination. That's how you get hallucination, right? So that's how the model will actually do things which probably you don't expect, right? And there are other parameters called top P, top K, right? And this allows you to make the model more deterministic, right? Or more creative, but also hallucinating, right? So be aware that you have these parameters to play around with, especially if you have access to the underlying large language model. So what is generative AI? This is kind of a branch, a subset of foundational models which generates new content, right? So for generative AI, the foundation model is still the basis, right? And then you can actually customize it based on, I'll talk about RAG, yeah. I talk about AI agents later on, right? And the new content can be multiple formats, text, images, audio, video. It is implemented again by training these foundation models or LLMs with huge amounts of data. Right? And very interesting, and what the breakthrough is that the kind of output they do is it's almost human-like. It's very difficult. It's very difficult to distinguish whether it's human or non-human. Number one, which beats that Turing test. But now I think in many cases, well, if you're talking about English, if I were to write a document, I think that generative AI can come up with better documents. Actually, the human capability. That's why some people are panicking, right? Super intelligence and sebagainya. No, it's just a statistical machine. So there are a lot of examples, ChatGPT for text generation, there's DALL-E for image creation, a GitHub Copilot for coding, then there's 11 Labs for audio, Runway for video. So I'm sure all of you know all these tools and have been using it. So how do you create an LLM or configure LLM to be something like a simple Q&A bot? So you think about that statistical thing. Okay, what is the most prominent university in Gombak area? Now, when I put a question mark, all right, what happens? It will say 60% is actually IIM in Gombak campus, right? And then UNI KL, British Malaysia is somewhere around here, 29%, and ITA UNT another 12% for this further, for example, right? So that's how, so again, you just have to use the LM, pick up that question mark as the point or the trigger for it when you come up with the next word and you get a Q&A bot, like a very simple Q&A bot, right? So this is very fundamental, but it gives you the idea of how you start to innovate using this large language model, right? So essentially, if I were to picture this, you get a prompt, it goes into this large language model, the question mark triggers, says, okay, answer is IAN and response to the user, right? So essentially, that's how a simple LLM architecture for creating bot. But you can also use more complex. So if you think about it, for example, I could say, hey, you are my travel agent, right? And this is my travel. I upload a file, my travel itinerary. Find me a hotel for an overnight stay. It has to be KICT because I'm bringing my wife, right? I don't have a lot of money, so I pay only 200 ringgit per day maximum, for example, right? Must have Wi-Fi, you must have a EV charger because I drive with EV, okay? And so on and so forth, right? I'm sure you've used that before, okay? Yeah, you query your Copilot or your chat GPT and so on. But in this case, it has to pass the file, it has to go out to CURL, and that's why most LLMs that you use today they have plugins on the back end, right? Which does all this. Look up another database, it does the search, for example, right? And so on and so forth. And some people call this, AI agents. It's an AI agent for you, right? And then what is it access to all data from booking.com, trip.com, and so on and so forth, give you options, and then they come and then you reformat and come up with a list of response, right? So in a typical architecture today, the LLM is not standalone, not everything is programmed to LLM, but it actually works with other kind of agents, right? Task searches and so on and so forth. And again, for those of you who are into cybersecurity, you start to see some of the attack vectors that can happen in this architecture. Very interesting. So what happens if, let's say, for example, I want to query something which is very specific to IIUM, right? For example, who does Ali report to in my organization, right? If you do that in a generic large language model, do it with OpenAI, it'll come back and say, I don't have enough information to answer it with. Right? So how do you make the LLMs actually tailored to your organization? There are a few ways to do this. The probably most, I would say, easiest way is to use RAG, or retrieval augmented generation. And what you do is you create this vector database. So if you know what embedding, right? You take your information that you have in your organization, you run through this embedding model, and then you create a vector database that you can actually do queries that allows you to get information which is very specific to your organization. So next time when I ask, who does ID report to, the app will actually first go to this vector database. And then it comes back, okay, retrieval is actually here to the Armanzo, for example, and then the query and the retrieval text gets pumped into the foundational model. Right? So that's why a lot of the large language models today actually can do RAG very easily. Right? It just needs to allow organizations to configure it, or the app allows it to do things like retrieval augmented generation, and the generate response will be very specific to your. Now this is about how you can tailor the the foundation model or the large language models to your organization, right? So this is a very popular way to do this. And there are other ways to do it, and I'll explain later on. But the other thing that important thing today, I'm sure you have heard about agentic AI, right? Again, I like to use the MIT definition. It's a new thing of AI systems, which are semi-autonomous or fully autonomous, enabling the able to perceive reason and on their own. So you think about it, I think when I asked the model to get me, a list of hotels based on my criteria, I kind of had a lot of human intervention there, right? I might come back and I might actually say, okay, I think I want even cheaper than that, yeah. But in the case of when you come on agents, the nirvana and goes, I just give you a goal and I just let it do it. So for example, it's just like the boss can the secretary, okay, go and get my flights to London and then leave it, right? And you trust this person to do it. So just imagine you trust an AI agent. Just give a goal and see if it actually works. Now it's not there yet, it's still evolving. But if you want to feel what the architecture looks like, I think there are many architectures, right? So one example in the case of AWS, what we do is we have this agent on one foundation model at the front end, taking the goals and understanding the goals, and then it uses kind of a chain of thought approach in which it creates a step by step what needs to be done and interfaces into a set of what we call action groups. And the action group actually does the actual thing. It's maybe a database, access to database, access to knowledge base, or access to another agent, does a search, and so on and so forth, right? But the point is that there's this chain of thoughts where, this chain of thoughts thinking, okay, I got to do this, this resources I can have access to, and then just keep it out and then right? And then the results come back to the agent formation model, and it gets to evaluate the result, right? Now, I could decide this is the result I want, and I can just improve, get it to think again, and go through this cycle, right? So, and the final results are sent to another gen AI, which does validation. And that's important because it creates this guidance, right? So this architecture is typically used for the, if you heard about this, the React method. And a couple of important components in the thing about Gen AI is one is the MCP, or the Model Context Protocol. This is like a USB, like, remember the Gen AI, they're just generating steps, right? They're just thinking about the steps. But actually doing things, they have to interface to others to do the action itself. And to do that, it will break the have a protocol, right? A standardized protocol that if I wanted to do a URL access is one, right? So the JNN knows what to do based on a standardized protocol. And this is a pretty new concept called the model context protocol, right? The other thing is this, in terms the React method is about you observe, the first AI that's observing, the second AI does this chain of thought, this reasoning, and then act is actually through this model context protocol. So this is one of the many examples. In this case, it also has guardrail implemented by another AI model. It's pretty complex, right? You think about it, and this is one of the many options in terms of implementing AI, right? Sorry, agentic AI, right? It's a still evolving area. I think it's quite complex. And now you're accessing, because the AI cannot access internal resources, like your database, and change the database and things like that. So it also poses a lot of risk for your internal resources. The first agent one, you don't have access to internal resources, all internal resources. But in this case, you start to have access to internal resources. And the other thing about this is that because it's interactive, you can have errors that they cascade, right? So that's one of the cascading error is one of the risks in terms of agency AI. So in summary, we think about LLMs. I think that's really good for basic use, like summarizing, writing, and so on and so forth. Simple to use, everybody uses it. I think a 2-year-old can use it, right? The moment you can type, you can actually use it. But then the downside is that it does not have access to to take you have to take care of the third party risk, and you need to understand the model itself has got risk, right?
Representative to public of jadi kita laptop itu tanpa cuma benefit ke background tak kena interrupt. Boleh tapi tak kena interrupt representative. Kalau kami dah cakap data semanda.
But the downside is that your database, remember that vector database needs to be clean, it needs to be good quality and so on. It's not that it also comes up with not good quality responses, right? So, for example use cases are like your internal HR chatbot. The next stage, the one is actually AI agent. This is where you actually can give either the LLM or a task, and it can do a response. And an example I gave just now was getting a list of hotels in the place that I want to go for some certain criteria. Now the evolving area now is actually agentic AI. This is where you give a goal and it involves multiple steps, multiple actions, and the results is based on the results of actions. And this is where I think a lot of organizations are starting to build their capabilities on, right? But I think it's still also it is also still evolving, and people also are trying to understand what are the risks because of the exposure of internal and changes that can happen to internal resources. Yeah. So, every good time to break. Okay, so we'll have a quick 5 minutes break. Perhaps you can take a break and go to the washroom and so on. But if you have any questions, I can take any questions or comments, right? You don't have to agree with what I say. It's the point of view. Online link.
Oh, yes, sure.
Is there any questions for those online?
Yes, so we are on for Q&A session for the audience in this conference room. If you have any questions, please raise your hands and introduce yourself.
Welcome back to KICT, Dr. Zahra.
Hi. Who's this? Oh, you okay, sorry. Yes, thank you. Nice to meet you.
Always good to see you. You mentioned about agentic AI. There are still issues with agentic AI, perhaps. I was recently being approached by one company, agentic AI company, that is backed by NDC.
Dia punya kat belakang dia.
That company was proposing to
Tak boleh kacau dia.
or suggesting quite familiar project with students, perhaps automating some of the tasks. So what do you think, Dr. Should we still need to wait or at least whether we should proceed or go for it? POC.
This is my opinion. I think all of us will have to eventually build this muscle to leverage on it. Maybe if your strategy is to use this third-party company, maybe doing it a good start. But I think eventually that capability needs to be within your organization, within you. Even as an individual, I've seen a lot of researchers that start to use this agency to automate a lot of the steps in research. I mean, you think about doing research, you guys start saying, you research paper, you research data, so on and so forth. Basically, you can automate it. Right? And that is the concept of agentic AI, right? But keep in mind, keep an open mind because, as I said, it's a very evolving area, right? So that organization might suggest how that usually react. There are other projects called Remove, if you've heard about it, where it's monitored and stay cheaper to do and stuff like that. So keep an open mind because as you go on, then you start to realize actually maybe you're not suitable for the way you're doing things in IIUM, you could use another methodology or another pattern. And there could be future patterns that other researchers or other organizations come up with. I think that is from Google and Remove is from Microsoft, I think. Yeah. But there could be other new approaches or patterns that you could use. So I would say yes, embark on it. It's okay for you to use the organization to do it, but I think eventually actually must the ability for you to leverage on all this AI to be within your organization, especially agentic AI, where you're actually leveraging on a lot of, I think, off-the-shelf platforms that is available, right? With the control, again, at the back of your mind, we're going to talk about risk and governance. That's all. Does that answer your question?
Yes, Dr. Very much. Thank you so much.
Any other questions online or?
Any questions?
Comments? Prof, macam mana? Mana Ruzang kan?
Okay, I have one question.
Okay.
Okay, so you have presented, I think, a lot from topics related to AI, from defining AI, LLM, AI is emerging AI yesterday. So I would like to ask you from your own opinion, what are the key competencies on student that our graduates should have so that they can contribute meaningfully to the development of the national AI, not only AI national development.
I think it depends on which level, right? So you guys talk about undergrads, undergraduate levels. Uh, Again, I always feel that really the fundamental body of knowledge is very important, right? It is super important because if you think about again all this AI stuff that you're talking about, at the core of it, that science has not changed in the last 30 years. There are breakthroughs, but really, if you look at it, people like me, like Prof. Food, we understand. We can easily understand how this thing works. Right? As I said, like even LLMs, they're a statistical machine, right? And you think about it, it's just training this huge neural network with huge amount of data, leveraging engrams and stuff. These are things which we knew how to do like years ago, but it is used at scale that the outcomes can be done in a very can be applied ways that we didn't think before. All right. So the fundamental knowledge of computer science, mathematics, whatever science that you're learning is super important still, and you shouldn't corner that. But what is important is also that as we do our projects, right, assignments and so on, I think the uh, the institution should encourage people, allow people to use the latest tools, right? That's available today because if you think about it, when you go out in the real world, right, that's those are the tools that you'll be using, right? You'll not be using, tools that came up 5 years ago, even 3 years ago, right? You'll be using the latest tools. So enable all the students or and you as students to actually use this latest capability, the latest tools. Now, the reason why it's important is on the tool side, obviously, because you want to be relevant and you want to, but on the fundamental side of knowledge or body of knowledge, is because this is how you scale. Because there's the time when you come up to work, actually, the technologies might change. But these fundamentals, you can actually allow you to learn how to learn this very easily, right? If I were to just teach, if you were to just teach tools, all right, you learn what which one the guy did. The tool is obsolete, you're dead, right? And you know how to learn, how to learn a new tool. That's why the fundamental body function is very important. That's how my philosophy and higher education keep fundamentals strong, but make sure the way that assignments and practical skills is actually leveraged on the schools. Now, for postgrads, it's a bit tricky, right? But for postgrads, it's a bit also easier because you are normally researching into new areas. So, and normally you already have a fundamental body of knowledge. So I would say it's a lot more flexible. Some may go into more fundamental kind of research, some may go into applied research. I think both have got value in it. But very important is about actually moving the needle of the outcome of the research. So that's my thoughts, like my point of view.
Any questions?
You're welcome. So you want to continue?
What time is
What time is it? Yeah. Okay, continue. And then we can take questions along the way. Yeah. All right.
We can have 10 minutes more and then we rest.
That's not possible, but then okay, very quickly, right? I think innovation strategy. So when we think about adoption of AI itself, I see that in three kind of layers. And the highest layer is using AI as an application, just like you use your ChatGPT and so on. You don't have to do anything, easy to use, no software as a service, like Copilot, so on, Gemini, ChatGPT, and like that, right? But the challenge there is that you have limited customization. And the second layer is what tailoring, your LLMs or your foundation models, your large language models, and so on. And normally, this is provided as a platform as a service, right? So, for example, AWS Bedrock and AI Foundry, Google, Vertex, and so on, where you can actually fly RAG, right? You can fine tune the models using your own data, or you can actually continue training. And you can also do agentic AI, which does fit the embrace right? So this is about again tailoring the foundation models to your environment. And the third layer is what researchers like us like to do, right? Develop my own model, develop my own LLM, right? Where you need the infrastructure, right? So normally people use the infrastructure service. You can buy your own hardware, your own GPUs. People get very excited when they can buy A100 NVIDIA, right? Happy, right? But interesting that NVIDIA do can just do it. There's one NVIDIA which costing 100,000 can probably just do you a query on inference on a meta llama 4.0. You need a A100, okay? Right? So that's how expensive it is, if you think about it. Yeah? So we think about using LLMs as an application. I showed you just how you can actually use the prompts directly, and then normally this LLMs will be connected to plugins, which allows you quite easy. For most of us, right, in terms of innovating, I think even this gives you a lot of capability, especially if it's non-technical. It's about the day-to-day work, right? There's a lot of productivity. There's a lot of things that you already can do without even any customization at all, right? So that's the highest most layer. It gives you a lot of potential integration across many areas. And I talked about the various tools that you have, and I think there's going to be more, whether it's Claude, you say DeepSeek, next time, you can have a lot of new models. Keep in touch as to what other new models out there which can come. DeepSeek is the last 1 year, right? And it could be tomorrow something else, right? So again, I think this is the part where it has really democratized AI for methods. Everyone can use it. Everyone in this room didn't raise their hands when I say, who doesn't use AI? Right? Everyone uses it, whether you like it or not. But the downside is you have to be aware it's actually the schedule AI. Now, if you think about using ChatGPT, how sure that sensitive document yang dicap CTS last year to not go into the model, right? Okay. So think about that. Yeah? It's very agile. Now, I talked about rank examples, an example of how you can customize the model towards your own organization. This is where you use that middle layer, right? Tailoring the model according to your needs. We talked about how you use rank in terms of implementing or taking a normal LLM and then having it respond based on the data in your organization, right? And you can do this in a way that this data doesn't get leaked into the model and so on. Just let me do that. But if you do it wrong, it can actually leak the model, right? So you need to know how to the data and so on. And you can do this for images. My late father was an artist. So I played around with this. I used so rather than rank, I used something called LoRa, right? Low rank what do you call this? Low rank education. So it's just like rank. I create this LoRa, maybe about maybe 20 of my stages. I put in this photo and I can take a representative of the the photo like this time. Right? So these are the kind of things that you can actually do with in this case it's a foundation model for image generation. Yeah. And we talked about also about agentic AI where you can configure this, which meets the requirements of your organization. I think this could be very important thing forward. So in terms of leveraging on this middle layer, I think it's in terms of saying, I think the easiest one is just to use RAG, right? Your organization. Agentic AI is probably next stage, right? You can use it as AI agents, for example. But if you really want to do something which is more permanent, then you can also use instruction-based fine-tuning. It's about taking an LLM, having it, let's say, your own data, like labels, and then you actually train models. So you just transfer learning to actually customize the model for your needs. Right? So this is more expensive. You need data scientists, you need, AI engineers to understand how to do all this thing. And finally, you can continue to train. Take an open source model, you have your own huge amounts of data, and you continue to train, right? You have it to be in the organization, right? So these are kind of the approaches that you take. But again, um, you still have to be aware of third party risk because it's using someone else's model, right? And then it requires more technical and data capability. Uh, so the final one is that what if you don't trust this model, right? This big tech companies that don't trust them, right? Or you have something that doesn't quite fit into your requirement. That's when you actually develop your own model. It's something like we like to do, right? We have our own model, train, and so on. So, and this is where you have to think about, okay, what are the AI structure? You can use the prompts you want, but or you can buy your own NVIDIA card and run your own system. Just one of the things that challenging is understanding the cost, right? So if you think about it, if I think about narrow AI, we're using things like statistical learning or maybe even simple non-neural network based reinforcement learning. We're talking about perhaps around about between 20,000 USD to a million USD development. AI. This story is good for example, simple like predictions on fraud, fraud information or financial information you want to do things like credit scoring, for example. Yeah. I think that kind of makes a lot of sense, right? But once you think about it, and I see there's a lot of interest people saying, let's create a foundation model for Malaysia, right? Yeah, so that you can use the Malaysian version, right? Of I think one of the things that challenges is that if you think about the growth of the parameters, so when I did, using a neural network, training a neural network on images to predict malaria, whether or not the swab has got malaria from malaria person or not. The image is about 120, 120, 120, 124 pixels by 124 pixels. That requires a neural network of about 90 million parameters, 100 million parameters. Okay. And I needed one NVIDIA GPU, card is about 200 cores, I think about 12 gigabytes. Right. That took a day to train. Now, when you're talking about, again, let's talk about, Llama 4.0, Meta Llama 4.0, you're talking about, I think, 400 billion parameters. Yeah? And today, things like Grok, it's 3 trillion parameters. Now, when you think about trying to run that, from a cost perspective, you can see that, for example, Gemini 1 is around about, just per training, we're talking about nearly 30 million. 20, right? And user cost is even more. Right? It's not cheap. Yeah? Just start the training, and then you probably got to train a few times a month. Right? To update the model. So I think one of the things that as we think about this LLMs, okay, I think that's where it's challenging. So I would say that yes, please be prepared. If you want to go for your own foundation model, you have to just be prepared of the kind of investments that people have need to put in, right? And maybe down the road there are ways in which you can reduce costs. But certainly today's technology, you're still looking at million, 200 million every time you train your foundation model. Now, I just want to touch a bit. Okay, before I go on in terms of innovation approach, I think obviously you need to leverage on AI as an and that's, I think, democratized. Start with that. Now, you have a bit more expertise, you might want to tailor it using, AI platforms. I mentioned about RAG and constant learning and so on. And if you really need to do it, you don't have any other choice, then maybe you should only my recommendation. I just want to touch very quickly on AI risk. Now, you talk about AI risk, I think there are three areas that we have to take care of. There's AI risk, there is cybersecurity risk, and there is privacy risk, right? And cybersecurity, we already have the Cybersecurity Act, PDPA for our privacy, it's covered by PDPA, so there is actually regulation. Fortunately, AI belum lagi, but I think soon there might be regulation. Yeah. Now, one of the things that I kind of get stressed is that people confuse between cybersecurity risk and AI risk, right? Actually, the way I see it is they are overlapped. There are some cybersecurity risks related to AI, but not all cybersecurity risks related to AI. So that's why when I talk to NAXA, for example, I say focus on the risk, cybersecurity risk, which is specific for AI. There is like overlap between cybersecurity and AI risk. But do not go into the AI risk because that would not be under your jurisdiction, right? Things like model drift. It's nothing to do with cybersecurity, right? But model drift can cause a lot of problems, right? In terms of the accuracy of the model and so on and so forth, and results in safety problems and so on and so forth, right? So in terms of thinking about this risk, I think you have to differentiate. But there are overlaps. Right? For example, if I talk about just AI risks, it's like misalignment, AI transparency. These are risks. Those principles, those are the risks which is specific to AI. We're going to have privacy risks related to AI. For example, if I train the model using private, personal identifying information, that becomes an issue, right? And also there are risks with cybersecurity. For example, adversarial machine learning, AI-driven threats. So there are actually this combination of, cybersecurity risk and AI risk, like overlap. So I think it's important for us to understand and distinguish between the three. Risks are real, yeah. I'm sure you heard about this Samsung situation where the engineers use ChatGPT, put in their source code, put in their technical documents because they want to improve the document and so on. Those information went into the model, and people asking, ChatGPT in a certain way can actually access the information. And they estimate the loss is about 60 million in terms of competitive intelligence exposure, right? And there are many others. If I had time, I would explain about all the risks. But given that there is real risk in AI, I talked about especially good agentic AI, where it's internal information. I think it's important for us to start to think about AI governance, right? If you don't want to start, for you to join in, maybe and AI governance is not easy either. Right? So, for example, if you're developing your own AI, you have to actually apply those principles that we have defined at every stage of your development. Right? But start with something simple. I always talk about this minimal viable governance. Everyone here is using AI already, right? Your ChatGPT and so on. I think it's important for you to have a board schedule AI. This schedule AI because you put it in university documents and I think it's at least start with a simple approach in terms of implementing governance for this minimal viable governance. People focus in general on tools that people are using so that you avoid scheduling AI. Right? And I would encourage you to do that. And the other thing I want to touch very quickly, just a few minutes, is that I know that UIA has got this, this program, KICT, what's it called? Thought process, right? Thought process. Maybe what you want to do is look at these principles that already defined, right? And maybe tweak it, right? So that, and that's some of the principles based on this, how they approach that, you are aiming at. And maybe that could be something which is useful, like for the nation, for example, given that you have this Islamic emphasis, emphasis, and that could be, and for all you know, it's the same principle. Maybe not. Maybe there's certain things that is our weakness, right? So this is something that you might want to actually think about. That becomes the thought. So, for example, when you think about risk assessment, you think about this is your principle in terms of the different threats that you actually have to manage, the controls that you have to put in place, so that you use AI in a way which is very useful. So with that, I want to my last slide is to conclude. I have lots of other slides. Out of time, I would just want to share my final thoughts. Last slide, sorry. I think whether we like it or not, AI is here to stay. Right? I think that some people are resisting it. That they're going to become terminators, okay. But I think it's about that because how we use it's a tool. At the end of the day, it's a tool. How we can, and that is why I think right from the start, in most AI communities around the world talks about the principle of user AI, and it's very important. You have to start now. You have to using it. Already using and glad, but there could be more sophisticated ways of using it. But as you do this, do not try to build this, deal with the AI risk through proper AI governance. Also from the start. We don't want to have to beat it up. Tesla dan langgar tiang mau kita nak tahu AI governance kan. Right? And it's always a risk-based approach. It's always a balance. You cannot be 100% safe, you cannot be, so it's always a balance between, benefiting from AI versus and addressing it. So with that, thank you very much. It's been an honor to talk to all of you. Welcome any comments, questions, if you have time. So we'll back to you.
Thank you very much, Mr. Zaharuddin. Any questions? Anyone?
Oh, no.
You can Please.
I've got a question. Just anyone. The one is after LLM. What's that? Will it be world model or something like that? And the second one, possibilities of API and KSI. Artificial intelligence. If you want to be the dean of KICT, go to San Diego. Okay. I think it is hard to say. I remember when I was doing the MIT course, and there was the same question: is there going to be anything related to your AGI, super intelligence, and so on? And the professors all like speaking answer like that. I don't know. Quite true, because to me one of the biggest, I guess, surprises as a computer scientist is when ChatGPT came out. Right? The time, just the quality of the responses exceeded human threshold, right? All right. So for me to say that won't happen, AGI would happen, and things like that, it's kind of very, very difficult to say it's going to happen and it's not going to happen. I don't think our current level of the general model LLMs are that level yet. I think it does very good, for example, very specifically in this case, the biggest breakthrough is NLP understanding. And what we are doing is that we're in the way to based on putting things together. That's what already happening, right? And you'll start to see LLMs become more and more powerful as time goes on. The challenge they have is obviously the power and cost training. All right. I have a feeling that the next breakthrough food that can happen. It really opens up new things that you can't even imagine it when it's really when quantum computing comes in. Because I think there are ways in which we can use this model that and where you can efficiently train. That means you reduce the cost of training, you reduce the power of training, the speed of training can be increased. And once it happens again, humans being humans, you know, ways that from testing, right? So that would be my easy answer to your question. So but I think you should be excited, right? And suddenly computer science becomes so sexy again, right? So exciting again, right? Like all this kan kita boleh buat kita own hardware and semua. Now we can do our own, things which is quite amazing. Now to your last question, which was actually I answered that question already. I think we should in computer science again stick to fundamentals, right? So that you can actually prepare students to learn how to learn, scale the table to scale. Because things are going to move. How technology and knowledge will apply is going to move very fast. But the fundamental knowledge is actually the same. All right. But then again, expose them to the latest tools, the latest ways of doing things, like methodologies and so on. I think in computer science, the core body of knowledge is about 5%. You're right. You have so much that you can actually do in terms of bringing together the latest approaches and latest methodologies for the early development. Do you still need to teach programming? Because I think I want just want say no need to teach programming anymore. No, that kind of thing. What you think? I still think we do, but we also need to learn to get students very quickly over that. So learn about the basics of programming, but very quickly also get them to learn how to analyze programs. Right? Because you think about it, if I use AI to code, someone needs to be in the loop to keep the link and the code right? Right? Yeah. To look at the white, what our own code, right? You can do that, but I've seen a lot of users actually having students to debug code or to analyze the code, right? To look at potential loopholes, to understand the code by the business. I think that's a skill probably you need to maybe enhance. But programming, yes, that's very easy. Thank you so much for your question. You're welcome.
Anita and her client have 40 years of experience in the employee. We have to show another session with this. As total kind of appreciation, I respectfully invite our need for commercial certificates to the work to present the topic of appreciation to the person. On Zoom and with the phone for the contribution. At the second session, we have this important. Thank you, Assalamualaikum.